So topic 2 is all about the origins of planet Earth and where it sits inside of this massive universe. And when thinking about our solar system and the universe, the question comes up, like, how could this be? Because Earth is just such a small, perfect planet inside what we believe to be an absolutely huge universe. Naturally, there's the non-scientific view, and I don't have too much to say about the non-scientific view. It's called creationism, and it's basically just belief in the Bible that Earth has a very recent origin or beginning. And if you were to look into genealogical tables in the Old Testament, there was an Irish prelate named James Husher who concluded that the earth was created by God in the year 4004 BC. So 4004 BC plus 2015 AD would work out to be around 6,018 years old. So 6,018 years old basically would say that the earth is very young, as opposed to old, which a lot of scientists believe. So creationism, certainly believes that Earth formed much sooner and is relatively young. The scientific view would suggest that the universe formed by this theory called Big Bang. And basically, Big Bang theory is believed to have occurred, the actual episode Big Bang is believed to have occurred about 20 billion years ago. And it's important that I state at this point in time that Big Bang theory is believed to explain the origin of the universe. It is not believed to explain our Earth in its solar system. That came much later. So if we were to go back somewhere between 13 and 20 billion years ago, we believe that all matter in the universe was once together as one big volume, and it was really hot and it was really dense and just a massive ball of gases that was under super, super high pressures and super, super high temperatures. And essentially this big ball of matter couldn't take it anymore, and it just exploded. And it flung all of that debris out in all directions. And it's actually believed that the event of all of the material being flung out in all directions is still taking place today. A lot of people talk about this thing called a expanding universe. And so when you actually consider, is the universe expanding? Well, there would have to be evidence for that. And so could it be that the universe began 13 to 20 billion years ago and things are still being flung out in all directions from that Big Bang? That's the question. Well, if you consider the raisin bun analogy, and I love raisin buns, so if you were to take dough, mix it with raisins, and if you were to measure the distance between any two raisins, in this particular case right here, you can see that the distance between these two raisins here is 5 centimeters. Naturally, you have to put that dough in the oven and you have to bake it, and naturally it's going to rise. And so naturally what you can see in this particular case is that the distance between those two raisins is now 15 centimeters. So basically we have 10 centimeters of expansion. How does that apply to the universe? Well, if you were to take a planet in our solar system and a planet in another solar system, and if you could measure the distance in light years between those two celestial bodies over a time of 10, 15, 20 years, it has been measured that the distance has been increasing over time. And that is basically our piece of evidence to prove that the universe is expanding, and we call that the raisin bun analogy. One of the things that's kind of cool, I suppose, is if you were to take a big blob of paint and if you were to put it in the middle of a paper, and if you were to take a spoon, think of that big blob of paint as all the gases and all the matter that's under super pressures and super temperatures before Big Bang actually occurred. Now you're going to take your spoon and you're going to slap that blob of paint, and that's going to simulate the Big Bang event. And naturally, if you could record that splashing of the paint, and if you could play that back in slow motion, you would witness all of the paint being flung out in all directions to kind of simulate how we believe our universe is expanding on a daily and annual basis. If we were to fast forward all the way up to 4.54 billion years ago, so way after 13 billion years ago, this is way after our universe formed, that is when we believe our solar system formed, which Earth is a part of. And we believe that formed by a thing called the solar nebula hypothesis, which we've basically break down into 4 different stages. So originally we think that hydrogen was the only element that existed in the universe. And under gravity, all the hydrogen atoms started to build up and started to form stars. And so within every star, fusion combines hydrogen gas to form energy in heavier elements. Like our star, which we call our sun. Naturally, we know our sun is on fire, but essentially it's just a star that's burning hydrogen fuel. And eventually, when that hydrogen fuel is all burned up, it will explode, and we call that a supernova. And when that takes place, everything will basically just be flung out in all directions as well. So every time you see a shooting star, it's essentially just basically like our sun that's burning hydrogen gas that actually ran out, so it exploded. Our Earth wouldn't be so good if we actually experienced a supernova, and that actually life on Earth would be done if our sun were to experience a supernova. What happens is that all of the energy, all of the material began to slowly rotate faster and faster. So this is essentially stage 1. So as you can see in here in the center, this little cloud right here, this is called a nebula. And so if you think about solar nebula hypothesis, this is the little cloud. All right, and so naturally it's as you can see out here and the outside, it's a really, really, really dirty solar system, very dirty. And so what's happening is that you can see that gravity is actually pulling all this stuff in towards the nebula, making it a bigger nebula. And that basically just represents stage 1. And if we were to, what we'll notice is that everything is starting to rotate in a counterclockwise fashion. And so I try to envision this like a CD inside a CD player that's actually starting to spin and rotate. Also, like if someone was to make pizza dough and they were to fling it in a counterclockwise fashion, it's actually starting to spread out as well. And in physics, we call this centrifugal motion, and it's actually pulling everything in towards the center here. Okay, so the center of this nebula here will eventually become our sun, which is our star at the center of our solar system. At stage 2, you can also see that outside of this proto-sun, this is a very, very, very dirty solar system. If you were to be out there in a spaceship, you wouldn't last 2 seconds. There would be just so much debris and particles that you wouldn't be able to navigate in your spaceship. It would be just so intense. And so as time goes on, what happens is that a lot of that debris outside of the proto-sun actually starts to collide with each other, and it starts to go through a process called accretion. And it starts to create little tiny celestial bodies, little balls of matter that's basically out there floating around. And they will eventually become the protoplanets. And so that is the first time that planets have been seen in these stages of forming our solar system. So if I were to look at stage 3, you can see that the sun is way more built or formed here in the center. You can also notice as well that if you were to look outside the sun in this area, that the solar system is actually way cleaner than what it was in stage 2. It would still be very difficult to fly around in a spaceship there. You'd have to be a really good driver and be able to navigate all of the objects and debris, but it's definitely cleaner. And also you can see in this stage these little tiny balls which are the protoplanets. And so naturally, as this solar system cleans up now, it's going to clean up by little things slamming into it. So the little balls, the little protoplanets, they're going to get bigger and bigger, and the solar system is going to get cleaner and cleaner. The same kind of thing that would happen if you think about a meteor that's actually out in our solar system right now that's flying around. Well, if one of those meteors actually came towards Earth and slammed in towards Earth, Earth would get bigger and the solar system would get a little tiny bit cleaner. This process is still going on. We know that there are still meteors and comets and asteroids that are out in our solar system that have the potential to slam into our planet as well as the other planets. stage 4. This is how everybody would kind of envision what our solar system looks like. Aristotle called it a heliocentric solar system, which means sun-centered. So we have the sun here in the center of our solar system, and Earth is inside here. And so down here we have our little tiny planets like Mercury and Earth and Venus. They would be in that area, and we call those the rocky planets. And then outside here you can see Saturn here, and you can see Jupiter. These planets would be more of the big gas giants. So rocky planets in closer to the sun, and the gas giants further out. Also at this point in time, you can see that the solar system is way cleaner than it was in stages 2 and 3. But as we know, there is still some debris out there. So just to summarize, Big Bang Theory explains the origin of our universe 14 or 13 to 20 billion years ago. It does not explain the formation of our solar system. We use something different called the solar nebula hypothesis, which is broken down into 4 different stages, and those 4 stages have been taking place since 4.54 billion years ago, which we believe to be the formation of our solar system, and Earth is within that.